Hi and welcome. Today we're going to measure a medium voltage breaker with EGIL. This is the small analyzer from Megger. And me today is Boel Ekberg, who's going to present this. I am the application specialist of the factory in Sweden from Megger. EGIL is a small timer which can do timing, motion, and also measure the coil currents. Today we're also going to use B10E, which we need to supply the coils and also the motor charging. We're going to measure on the circuit breaker Sacher. It's a 12 kV medium voltage breaker. It has 3 phases, the upper and the lower contacts. It has a motor mechanism, a common mechanism for all 3 phases. I'll start with connecting the plus and minus of the motor charging on the instrument. Plus and minus. I connect plus and minus for the motor on the object. I continue with connecting the coils. I need the supply, plus and minus for the coil. The plus creates the pulse, so that goes to the instrument. And we need to meet with the minus on the circuit breaker. I connect the pulses on the instrument, close, and open. And I continue on the breaker. Close and open on the breaker. I connect the timing leads, main contact, and connect on. I connect the main contacts, timing, 1, 2, and 3 on the upper contact. 1, 2, and 3 on the lower contact. Since the cable only have 4 connections, I need a normal sense cable to intersect, to connect between the 3 lower points. I continue with the auxiliary contacts, and I connect the auxiliary contact on the instrument. And on the object. I connect the auxiliary contact timing over the close contact and over the opening contact. Let's go over to the mounting of the transducer. To do this, I have prepared the different parts from the ready-to-use mounting kit, the clamp, the arm, the white holder, and the transducer. I need to mount the details together. Steady. I go over to mounting the transducer in the white holder. And the flex coupler at the axis. This must have a distance in between here. And the cable is connected on the other side. And now we're ready to mount it on the circuit breaker. I have connected a part from the rotary kit on a rotating point in the mechanism. This rotating point reflects the motion of the pole. I have prepared the angle so I can easily connect the transducer. I need to connect it steady with a C-clamp and adjust the angle so it's aligned and properly and steady. And I have to connect and adjust the flex coupler. I need to extend the motion cable to connect at instrument. I turn on the instrument to check that the transducer is in correct position. I go to Menu and I move to Monitor. Here I can see that the transducer is on 45%. I need it to be between 40 and 60%. And if it's not correct, I need to loosen the flex coupler again and turn the transducer a little bit so it is in this region. That is because the transducer has a gap and we want to avoid that gap during the measurement. I have one more preparations to do. I need to charge the motor. I use B10E. I put it to motor and I set it to the voltage I need. And it's going to be a little noise. After that, I put it to coil again. I've connected the EGIL with my PC. I start with creating a new object, a new breaker, and I give it a name. I select the test plan, and I need an EGIL test plan, and I want to use one with motion and no resistor contact. So I select BM8012 EV. I continue with setting the stroke. I use 100 millimeters because I don't know the stroke of this transducer, so I use a simple value as 100 because it's easier to calculate if I get more information in the future. I extend the measurement time on both close and open operation. I know this breaker is slow and I need enough time to catch the whole motion, not only the timing. I save, and now I have my new object in the list. I continue with creating a new test. And start with a close operation. I push new recording. And select uncalibrated transducer and OK. I push measure and will continue with controlling the breaker from the analyzer. One preparation is still to be done. We need to connect over this to get the continuous plus here so we can control with the instrument. It's going to be a little bang. I turn the knob. And in a little while we will get the graph on the screen on the PC. I get the 3 timings, red, yellow and blue. I get the coil current, a very small one, and a motion. I will move the motion layout a little bit, just the Y scale there, so I can get it a little bit higher up in the position. I move it to position 6. So we have the motion in green. Continue by closing, saving, and doing the next operation, an open operation. New recording again, measure, and I need to turn the knob again. And there's going to be a bang. And again, here I get the timings. It opens about 45 milliseconds. And the red coil current and the green motion. I also can see here in the parameter list that I was saying wrong. It was actually about 54 milliseconds. It's easier to see it in the list format. And the maximum current was 0.5 amp. I close it and save it. And now I want to do more measurements. If this was in the real world, I would actually do 3 of each kind. But this will be the same procedure, so I close here. But what you need to know is that in this situation, I have actually only done 1 proper recording, because my first measurement was a calibration. So this one is actually not considered a real motion measurement. This was all I wanted to show you today. Thank you for the attention and welcome back to the next webinar.